Hello. It is time. Alright, so before I jump into Godot, I'm going to review what I'm doing. Might be a good idea to consider. To consider the things that I'm doing. Instead of mindlessly running into every day. Alright, so what have I got for character controller? I can make these I've got like none of these actually. So what I've done so far is I have it walking is applying. I can walk on other ridge bodies and I'll move with them. They push me along. I'm using friction forces, essentially just saying take the ground and try to stand on it. Essentially just applying friction opposite to any ground motion. Alright, I guess I gotta open up Godot to see exactly what I have. But I need to try to be intentional, right? It's important that I get this done right, but also done efficiently. And I'm not spending a lot of time doing nonsense things. So far it's working well. It is taking me a while sometimes to, you know, find a mistake that I've made. Especially yesterday, I think it took me a really long time to figure out a problem that I had with, I mean, getting, okay, well, we'll just ignore that for now. Getting onto platforms and moving, having them move me, has been a bit of a struggle. That's cool. When I walk around, that'll do that. I feel like, I mean, maybe reticle would just help me know exactly where I'm moving, but third person is weird. I probably shouldn't even think about it, honestly. Alright, I gotta, well, that's one really annoying thing that I gotta figure out. Okay. So I have a problem right now where, okay, let me just do like to-dos. Today. Let me say today. So the first thing I'm going to do is I'm going to that problem can be fixed with step down. So when I move off of a surface, I can come down. I'm thinking what might be possible, or might be the preferred solution, is to make it so the sphere cast actually sits lower, or projects lower, and then I use my height offset to pull myself down. So this height offset is essentially a max length reduction. I'll look at exactly what it is. Max length, my offset is this minus the height offset. So this becomes my rest length. Hey, Denlin. If seasons are inverted between north and south, it means that there's an exact point on the year where it's either rainy or sunny on both sides of the world. What? I maybe just mean like the same season. Which, yes. Those, I believe, are called the equinoxes. Which happen to be fall and spring. Let me ask Rock. Those are called the equinoxes. The autumn and spring equinox. Alright, so that would be a step down thing. However, I think it's probably that my... A stable move is pushing me up. I can go ahead and make it so that stable move just will not lift me up. Like if I have force ground movement, I can just take off that vertical motion. I can also solve that with step down. So what happens is when I hit an edge, I will launch up it. You know what? You know it's a good idea. Let me skip the steps for now and probably get a ramp in here. And just walk over the ramp. Let's put these things at the top so they're like up there. I'll call this floor. I'll call this step. I'll have ramp. Just delete that. It's called the equinox. Oh, wow. Wait, there's not just a ramp? Oh, no. All right, well, I may... All right. You're being so silly, man. What is that? 8. What does that have to do with horses, though? I don't know what... What? I don't know. What do you mean horses? Alright, so in here, as soon as Firefox decides to allow my mouse to interact with the page, there we go. You're mixing the equinox and equine. Alright. In add-ons, I put in add-ons, CSG Extra, ramp. So, okay, so I do like this stuff. I might copy it in here. Though I think what I'm really going to do is I'm going to leave curve out of it. I'm just going to grab, I think, ramp and steps. What is this poly resource? I think that's only used for CSG Polygon 3D. CSG Polygon Res Poly Resource. What am I doing here? This looks weird. Box 3D. I'm seeing things move on my desk. Box 3, okay. So these can just be imported. All right, I'm gonna grab these files and just start copy pasting them in here. No, I want a folder. Oh my gosh. Extra CSG nodes. So I just need ramp and steps. I'm just gonna do ramp and steps. Copy. What is it? Oh, that. Okay. And then I want steps. Alrighty. Now as an add-on, I have to put that on. Unable to load add-on. CSG Extra plugin. Right. Right. You're right. I guess it is technically an editor plugin, but for now, I'm just gonna say why is that a plugin actually? This is a nested plugin. It's curve point. I want curve plugin. I think I just should mess with the configuration and get rid of the fact that it loads a file. I'll just take that out, I think, and then it's fine. Yeah, and it's just the scripts. Okay. Alright, let's do reload. Maybe? Maybe I reload and the things are there. Visual instance, geometry, CSG, primitives. Why is it not there? Does it really just have to be a script that does nothing? Okay, so it's got to be a script that just does nothing, I guess. I can't. Weird, but okay. Nope, 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 nope. And these are actually just mass. CSG extra plugin. Okay. Now this loads. Those things should be there. I go here, add, node, visual, geometry, CSG, box. There we go. All right, ramp. All right, so let's put the ramp over here. Yes. Okay. Let me actually do like 05, I think, and then this should be lifted. .5, and then yeah, that just extends it. Okay, so let's do 5. A big ramp. Let's go 2 meters. Collisions handled on the outside. Why is this not exactly? I don't know. Whatever. Isn't it like a what is it? It's a 3, 4, 5 triangle. So 3, 4, 5, 3, 4. Okay. 4, 3. No. 3, 4. What am I missing? I want that angle to be... Somebody managed to beat Minecraft without moving. I think I've seen that thumbnail. What do I think of here? I want to have like a 15 degree and then I want like a 20 degree. I guess I can just look up triangle side. calculator. Oh, look at that. I would like... I have two, but I have two sides. Why are you asking? Omnica. No. Right triangle calculator. I have... Yeah, see, this is going to be 4. 4. 3, 4, 5. I was right. I want alpha to be 20 degrees. Let's start with like 5 degrees. And then I want height. I want B. Okay, height can be whatever I want. B. Do I have to give... I have to give C, I think. Oh, I can give B as well, because I actually should know this angle. Oh, no. If I give... If this is a right triangle, I have side angle side. Okay. Or angle, side angle. So if I say I want you to be 8 meters long, I should be able to get the rest of it from that. Okay. So A should be 0.7, and then B is 8, A is 0.7. Okay. 0.7. I think I said 8. 5 degrees. Okay, because I'm going to have a bunch of ramps that are like increasing in that. I guess that it technically is like 69991. If I put in 5, yeah, okay, whatever. Whatever, it's close enough. All right. Material, we're going to load up. Grid white, I guess. Let's do green. Nah, let's do blue. Okay. Degrees. We should be 1.411. And then 1.411 half. What the hell? This is weird. All right. Whoops. Just going to reload the scene. Okay. Strange behavior. Great. 15 degrees. I'll do like 20 and then I'll go 30, 45, 60. It's going to be 2.1436. Sure, whatever. Why does it do this? Oh, no. No, yeah, it is messed up. Whatever, I can just line it up and then... $20 degrees. 2.912. So now 30 degrees, and I've seen other ones where they have this, like, crease thing. I don't think I really need that, but maybe it'll just be good to know what happens. Also, I've been kind of messing up. I can just copy this value and paste it. Save myself some typing effort. Yeah, this behaves really strangely. This is just like, this is definitely just like a mistake with my scripts. Where like it loads or does something weird. I don't even need to know 45, I just know it's gonna be the same. Eight. 4. $13 point. I can just copy. I don't know. I really don't know why I'm trying to. That's equal to 8 over root 8 times the root of 3. Cool. And I guess I'll go for like 80 degrees. Okay, that's like really tall. Maybe I'll just make this one shorter, like 3 meters. 2 meters. As like a value very close to a wall. Then I should just be able to reload this scene. Alright, you know what? Let me just say that I'm going to go down a meter every time. Or something like that. Oops. Should be 7. No, what? Oh, there should be 3? What? 3. Yeah, this is like really messed up. yeah, I can probably bring this down to like 1 meter. Gonna stream, you better be productive today. I will be. You as well, I hope. Degrees. For sure you can find test levels with those shapes already. Yeah, but I can also just make it and it's really not that much time to make it. I definitely made these a bit longer than I needed to make them, I think. Also, it would definitely take me longer to go copy something in than it would just be to make it myself. 100%. Without a doubt. I'm gonna stream. Alright, yeah. You have fun. Yeah, I'll bring these all down to... I'll make these a bit smaller. They definitely take up too much space. There's no need for them to be this large. Okay. Ramp. Okay, there's some ramps. Let me go walk up these. I'm expecting these ones don't launch me. Unlike like these ones do. I should just walk into it normally. They kind of bounce up a little bit. It seems like... I said that already. Am I dumb? Yeah, you did say that already. Alright, there's got to be a mistake here. Because if you look at what's happening, you know, I'm skipping up very high, and when I walk down, I compress into it. Which is probably not... Wow, that launches me. Yeah, okay, so... I'm going to say there's probably a mistake happening here. There's probably a mistake in my logic. This is not exactly... correct. I mean, what it should be is this is 90 degrees to the normal. So if my normal is like this, I should be like that. So at the very least, up should be pushing me kind of into the ground, and down should be lifting me kind of off the ground. It seems like it's going in the wrong direction. Up is pushing me off the ground, and down is pushing me into the ground. It's like, this is the slope, or this is the normal of the slope, this should be my vector. What's really happening is my vector's like this. And it's also pushing me into the ground for sure. So, this could also be ground velocity, or friction is being strange. So, I mean, let me just print it all out, I guess. I will print my... You know what? This is... Okay, I think this is the point where I need to have a debug thing in here. I want to display these vectors visually. So... how can I do this? I can do this... I actually don't really know how to do this. How to display these vectors. If I can get some kind of vector display thing, how do I do this? Alright, I need to go look through... I probably need to go look through... I'm gonna close these. Yeah, let's close all the jolt physics, probably. I was looking at those so that I could find some stuff. Let me see... I don't know, debug? Curve resources used by path nodes will be visible in the running project. I don't think I want to use that. I just want to have my own. I kind of need like a proper debug thing. Okay. There's this draw line script that's somewhere around here. Draw line 3D. I'm gonna look at this and see what this does. It's a node 2D. Draw, get viewport, get camera 3D. Screen point start is camera unproject position. Oh, okay. It's that simple. And then it draws the line. I mean, okay, what I really want is... I don't want this to happen. If it's behind the camera, I would prefer... that it would do some kind of logic that it can still draw this. I guess just like clipping it, right? So I mean, really what I can do is I can just say, is position behind? I mean, is position behind is kind of there. So I can say if either position is behind the camera, then what I should do is I should project the point onto the plane of the camera, onto the camera's plane. So plane has, there's a plane projection class and function that I can use for that. So lines should still draw correctly, because projecting it onto the camera will, or projecting it slightly in front of the camera should have the same result. Okay, so I'll say this. Yeah, I need to have... Okay, where can I put this? I guess I can make it an add-on. Right, why not? I'll say debug shapes. Debug draw. I mean, I don't know why I'm doing it like that. What I should say is... Oh no, please, 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 please. Why is this crashing Godot? Why is that crashing Godot? Come on. Why? It just straight up crashed Godot. That's just... The pop-up appeared, I pressed enter because it was on remove by default, and then it just crashed. It went totally unresponsive. Oh man. Delete. It can't do it. That's crazy. Godot can't do that. That's just crazy. Alright, so I gotta go delete it manually, I guess. I have no idea why Godot can't delete that folder. It's impossible. It says it's open. It's not open. Nothing has that open. Nothing had that open. I even restarted it and tried to delete it and said, oh, you can't do that. Alright. Plugins. Create a plugin. We'll call it Debug Draw. We'll say subfolder Debug Draw. Me 1.0. Script name. GD. Draw lines and shapes to the screen. Turn that on. Awesome. Okay, so I don't need any, I don't have any auto loads or anything like that. This is just going to be it should be something like this, I think, where I have guide, plugin, add autoload singleton. Okay, so I want to do that. I want to do the add autoload singleton, and then I give it the name. Cool. It should just be like that. Enable, disable, so I just give it this. Can I actually just call it draw? I'll just leave it named debug draw, whatever. And what's the best way to do this? Path string. All right, let me go look at the documentation on this. Auto load. I was thinking maybe it will be relative, and you know, maybe it is relative. I'll just create the script, I guess. It's a Node 2D. I'm just gonna write it like that and see if that works. Let's just see if that works. I probably need to... I don't think I have to call a tool. I'll just print. And then I'll see... Project reload. I kind of hope it just prints it. It didn't print it. Let's launch. Okay, it didn't do it. Project settings, globals. Alright, I guess I actually have to write it like this. I also don't think I have to reload project. I definitely don't. I don't have any constants that need to be rerun. There it is. Okay. Oh, no, that's not it. It's not there. Okay, so what does guide do differently that I don't do? Add-ons guide. It definitely just didn't do it. Request for Request for non-existent project setting autoload debug draw? What are you talking about? Add autoload. Okay, just weird for some reason. I have to turn it off and on before it works, which is just strange because I would think it runs enable plugin every time you... Actually, I guess not. I guess the enable plugin actually only runs when you click that box and literally no other time. Alright, whatever. It's there. And if I hit run, I see loaded draw. Okay. Alright, so... It is a node 2D. It will draw to the screen. Technically, it would be ideal to draw this, to be able to tell it to draw over certain shapes or like under things if they're in the distance. I mean, if I draw, it's drawing on top of the screen. Whatever. All right. I'll just make a function called vector, and I give it a vector, and I have a length. So what this will do is it will draw a vector at a given position. length. All right. The debug or the draw line thing uses process. If we have lines, then we queue a redraw, and then we have a draw. Or a line is removed. Whatever. Okay. Draw character? Font? Position? What other draws do I get? Dashed line? Polygons, a line? Um, let me check something. When I have like camera project position. What? No, no, no. What? Unproject. I want to go see what unproject position does, because I feel like it uses a plane, and then it just calls plane. And same thing with position behind. I feel like it just does plane stuff, and if it does, then I don't even need to use those methods. I can just create a plane and pass the plane. Dog. Dog. Yeah, I'm gonna have to go take the dog out. Oh, I can look at it here. On project position. Alright, I'll be back. Taking the dog out. I'm back. What was all this? Why does it not actually open? Why does it not go to that? Get near plane points. Huh? Also, I realize this is definitely not correct. Using a plane was definitely not correct because it's actually... Okay, well, I guess they do make a plane from that. Projection transform the plane. Okay, they're doing like math though. It's not... Yeah, it's not that simple. I'm sure there's a way that if a point is behind the plane, is behind the if I have a ray and the one of the endpoints is behind the camera, I should be able to cast that forward until it hits the near plane, I guess, and then set it there, right? If they're both behind the camera, then I can skip it. But if only one of them is behind the camera, then I need to cast it in the direction of the point that's not behind the camera. Let me see what they say about this, because they definitely had... Okay. When you do this to position GUI elements, use is position behind to prevent them from appearing if the 3D point is behind the camera. the blue part of the linked diagram, this diagram. So I actually care about is in frustum. Near. I guess that's also if it's beyond any of these, then I need to... Alright, so I will need a function instead. That would be like, this might even be something already. Never mind. Clamp position to camera frustum. Well, if they're a sequence of planes, then I would essentially just say if I'm in front of if I treat it like a box, right? If I'm in front of the near and behind, or if I'm in front of both the near and the far, then I can draw. I'm somewhere in here. I guess that doesn't mean vertically or left and right. I'm trying to think of like the logical way to determine if we're in view. Near, far, left, top, right, bottom. Oh, intersects ray? Why is that a variant? If no intersection is found, null is returned. Okay, so it's a vector 3, but it has to return null to say there's no intersection. Oh, and there's an intersect segment. So that's exactly what I'm looking for. I just have an intersect segment near plane, on the near plane. Same thing with a far plane. So I can make sure it's always drawn properly within bounds. Okay, so yeah, the planes are great. The planes are great. I want to see if is in frustum what that method looks like. Because I want to see if they do a clever thing. There's a certain thing that I'm looking for, and I want to see if they do it. Is position in frustum. Is point over? 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 Really? These planes are facing... So the near plane points towards me, the far plane points that way. Okay, so it's like a box with the planes pointing out. Okay, honestly, I thought they'd be pointing in. That's okay. So I can just say, in fact, what they do is they just do get frustum and they iterate the array. So I'm just gonna do that. So what I can do is I can say kind of what this one does, where I think I like get the active camera somehow. Get viewport, get camera 3D. This is viewport ancestor. Camera 3D. It says near, far. Oh gosh, where am I going? Near, far. I'll just copy this whole thing. Near, far, left, top, right, bottom. Just don't use that enum to can I say like int? Whatever. Do a redraw, and then I can actually just return. And then I can say, Let me actually return like an ID as well. An integer ID. Let me just have a method that's like get. Otherwise, I don't want to store it in items, so I store. Somehow I store this as a vector. So I guess I say actually, I'll just say if it doesn't exist. I just update the ID. This is a problem though. If I provide an ID that returns something that's not the same type, then it's a... I mean, I guess I can just modify the type then, right? Whatever. I'll keep the ID, but then update the type. No, it'll be a warning. No, yeah, it'll be an error. I'm assuming this will just like print out the enum. If ID is, let me see if ID is less than 1. Okay. And then yeah, this just will continue, and then I say and honestly this is all gonna be let me do because I'm gonna have other types and I just want all this to be pretty much identical the whole way through. Okay. What can I do with enums? Enum. That's not. Okay. Uh, if you pass a name to the a constant dictionary of that name, the named enum. What do you mean? Okay. So you get a key. So can I obtain the key of a value? Find key. Ah, okay. Okay. That's what I really want. There we go. Updating item as blank type, but it is a blank. Okay. So I just say ID get, and then I can do stuff in here, so that I can just say item. Okay, cool. So what I want to say is I want to say like a segment. So I want to say like clamp segment. So it can pass through one of the planes, but then just set to one of the plane. So, but also if it's a segment that passes through front and far, or near and far, but is otherwise contained, which means what does that mean? I guess what I really mean to say is like draw a segment. So vector is just the same as doing okay, so here's what I want to do. I want to also make it so I can draw like text at a location. So I think I want to draw like the vector like direction. I don't need the letters. I just need to see the lines, really, is what I need to see. So for the vector, what I really want to see is I want to see the starting point and then in some direction and some distance. The vector will encode the direction and distance. But if I'm drawing a segment, I mean, I guess I don't really need this right now. All right, I'll just say I don't need it right now, and I can get more serious about it later. But I do need this item thing so I can make sure I'm constantly updating it. And I can just queue redraw from here. And it's just processed after. It should be processed after everything else. Actually, no, it'd be processed really early, in fact. So what I'll actually do is I'll just go through well, drawing actually happens at the end, right? I think what I want to do is if I'll do items get item. And then I'll say this, when I do assign, I'll even say it's down here. Well, it's actually get item. So in fact, I will put this code in here. So he's just standing there staring at me. He's still just standing there looking at me, wagging his tail. I don't get it. What are you doing? What are you doing? What do you want? I don't think he needs anything. Just took him out. What do you want? He's just... Alright, I gotta go see what the dog needs. I'll be back. I'm back. Okay. So yeah, I need get item to do that in case it was queued to delete, because this process should happen before anything else in the scene, because this is going to be like above the world node. This is like the scene. This would be like a child of wherever world is. So it may happen. It should be able to happen first. Processing here should happen first. Auto load. I mean, I can even hit run and see. It's gonna fail, but oh, okay, it's just gonna totally fail because it's S. So if I hit, okay, weird. If I hit remote, you see, oh, yep, see there's debug draw. So this will process, I believe what it does is it does breadth, or no, depth first. So it goes into guide, it processes the all guide. Then it goes to input manager, processes all that, or this gets processed, then this gets processed, this, and it goes in order like that, I believe. So debug draw will tick all of these down and queue them to be deleted, but then I may come in later and say, all right, I want to draw a thing. I want to update something that is on a timer, like a very short timer or something. So to make sure that gets any queued deletion is removed if I modify it. Yep. So we queue a redraw, which is basically just at the end of all process. Then we say, all right, I like to get a draw later. But then if I end up trying to delete something, then I will queue the redraw and then draw. I just go through all the items. If the item says to delete, I don't draw it. I'm not allowed to delete during iteration. So what I can do instead is I can just do keys. I'll just do it untyped. Okay, so we're moving stuff. And then I can just do like a match, I guess. I think match is always slower than just writing the if, so. So I do draw vector where I grab I just call draw vector. Okay. And it's just that simple. Now draw a vector will, for now I'm not going to worry about projecting things correctly. I'm just going to I mean, I could say like clamp segment to get a pair of vector 2s, just be a vector 4, I guess. And if I return like, or just a vector 4, and if I return like an infinite vector or a non-finite vector, then I just say, all right, well, this segment straight up can't be drawn anywhere on the screen. So yeah, I'll just do that. I'll just say, I'll say pause. And if we're not finite, just return. If the segment does not intersect the frustum. So essentially I have to say, I guess if I think about it, if I have an arbitrary segment, it has to intersect 2. It could intersect off, though. I was going to say it has to intersect 2 frustums. All right, I guess what I can do is I can say, I try to intersect the ray with a plane. And then if the point on that plane is in front of everything, then it's in my bounds, right? So I could just say, what's like the math for that? Because ideally I would intersect with like, you know, a quad. And if I intersect with, yeah, if my ray intersects with any quad, then I know it's in bounds. Because essentially what's happening is that this is more drawn like the planes extend out infinitely, right? So just intersecting two planes doesn't really mean it, because I could intersect like outside of the view frustum. So if this space right here is inside this space, my face is inside the plane, I can intersect out here, somewhere down here with these two planes, and that's not inside, right? I could say that both my points have to be Jeez, this is really strange. Maybe I need to draw this out. If I generalize it to 2 dimensions, 3 dimensions should be the, you know, the same, right? So essentially the problem is I have planes that are like this. Let me even draw it more clearly. The planes are like this, right? So this green area of painted green. So this is my inside area. So if I have a segment, I could have a segment like this. I will trace my segments as blue lines. I can have a segment like this. And this intersects these planes here and here. But obviously, that's not inside. This is not inside, right? So what's the difference in this case? I guess the difference is the two planes that I've intersected. This intersection point is ahead of the other plane. And this intersection point is ahead of the other plane. Maybe that's the difference, right? So if the two planes I intersect are... See, this intersection is behind the other plane, right? Like this. This intersection is behind that plane. So then I know it's not true. So if I intersect in both points, actually it's kind of like if either point. I'll say that. I can intersect two perpendicular planes, like the bottom and the right or the left. I guess if I really consider it, it's more like this, right? So let's say I'm intersecting with this plane. I'm checking this plane intersection and this plane intersection. We have one intersection here and we don't have an intersection with that plane. It doesn't intersect it. So what I could say is, all right, I have an intersection. I don't even need to do that. I just check every pair. Every pair of 90 degree, every pair of perpendicular planes. Essentially what I really need is I just need a function that says, do I pass through? Or not even just I pass through, but once I've detected that I pass through, I can then clamp this point down to here, the intersection point, and this one down to here, the intersection point. There's also the edge case where I have a line segment like this. So I have a point that will never intersect anything. It's the point always reads as being in front of everything, so I can just do a pass over each point. And if one of the points are inside the frustum, then I know... actually, I guess that's the case, right? If one of the points is inside the frustum, I know for a fact it intersects with the frustum. The other point intersects with a point somewhere else. So I guess what I could do is the ones that it is in front of, I just continuously project back. I project points back, essentially, until it clamps onto this region. Yeah, let me think of that. Let me think of a point out here. It is ahead of this plane and this plane. These planes point out. So if I project onto this one, I end up projecting it here. And if I project onto this one, I project it here. So it ends up at the corner. Right? And then this would also just extend to like the front face. I just project it flat back onto the front face and it'll clamp up, right? Okay. That's actually a simpler way to do it, I think. I check each point. If a point is behind everything, then it's inside of my frustum. Whatever it's ahead of, I can project it back. I just literally, I mean, that's exactly what I do. I just project it back. If both points end up projecting outside, I guess I get a degenerate. I would get a degenerate case, in fact. Okay, so here's the degenerate case when the whole segment is outside. These 2 points, this one would project here, and this one would project. Really? It would project like this. Huh. Okay, so in the case where one of the points is inside, oh, wait, what? Really? A point in here and then a point out here. Yeah, okay, so this is actually... I guess that doesn't work, right? Yeah, that actually doesn't work. I guess what I can say is if I'm in front of In this case, I'm in front of one plane. So what I have to do is I have to trace back into, I have to intersect with that plane. I'm ahead of one plane, I intersect with that one plane. Using this segment, and that's exactly what I do. Let me consider this differently. I'm going to draw my lines differently. It's like it's more like this, right? My plane could look like this. Recent colors. Okay. So my plane kind of looks more like this. This is like a side profile view. So if I have a point here, this is ahead of this plane. It's behind this one, it's behind this one, it's behind this one. So it's ahead of exactly one plane. And I have a point on the inside. So what I can do is I can intersect and use this point to draw. Or well, yeah, I would intersect, move this point here. It's ahead of exactly one plane. If it's ahead of two planes, like here, I want to draw this in a certain way. To here. This is kind of like a rare edge case, right? What I would then do is I intersect with either of the planes. I guess I should intersect with both of these planes, right? Okay, let me draw it a little bit better then. Or in a more common case. I intersect with both planes. I get this intersection here. This point is ahead of both these planes. This intersection point is ahead of this one, so I discard it. It's ahead of the other plane, so I discard it. So then I intersect with this plane instead, and I get this point. This point is behind the other plane. So then I know this is the point to use. So if the intersection point on plane A is behind plane B, then I know I'm good, right? Now in the three-dimensional case, does the 2D case hold up in 3D? I mean, it should hold up in 3D, right? Assuming that these 2 points are both, you know, as far as depth goes, in the same location. But when I add depth, this means I now have a case where one of the points is ahead of 3 planes. So the point, so I can just kind of do the same thing. I intersect with any plane. And if that point is behind the other two planes, then I know it's a good point. And that should happen at least once. There should be an intersection. If one of the points is inside the frustum, there should be a plane I can intersect with that it is behind or on top of, I guess, other planes. I guess in this case, what I can do is I say, in fact, if I'm, the same thing actually applies here. If I'm ahead of two planes, I can project back onto both planes to get, no, that wouldn't work. Because what would happen is I would actually shift it down here after doing an intersection. Okay, let me start with the trivial case. Both points are ahead of the other. So I'll say, I kind of want a data type that's like a bit thing, like an integer. Yeah, I kind of want to do this. So I'll just say collect for face in frustum. For index in the length of frustum. I guess actually what I should say here is skip if I don't have a camera. Okay. Would it be like, I guess you can just say this. If base is point over is point over. If start is over this plane, then S. Yeah, I want to toggle the bits that it's ahead of. So I believe I can do or equals. So it starts at 0. Yep. Whoa. Okay. If this value is 0, so if s frustum 0 and trivial case, both points are in the frustum, then I can just return out to 2D world space. A trivial case, 1 point is outside. So I'm going to have an in and an outer point. Jeez, the number of times that I hit enter is crazy. Enter equals and hit enter 3 times there. 1, 2, 3 at the fucking tab end somehow. First enter is confirm, and then like, I don't know. It's just stupid. Sometimes I have to hit it 3 times. So I have an inner point and an outer point. So then what I want to do is I want to find the faces. If it's ahead of one face, I intersect it. If it's ahead of 2 faces, I'm in 3D, so if it's ahead of 2 faces, then I have to find one of the planes that intersects. If it's ahead of 3 planes, then I can just... It's actually the same way. I have to intersect it and find the intersection point that is behind all the other planes. If it's ahead of 4, I don't know if that's like physically possible, but hit down on. I'm so good at optimizing meshes that I put entire castle thing in only 1.4 megabytes. I don't actually know how good that is, but good stuff. So if this is ahead of one face, so what I want to do is I want to say Is there a count ones? Pop count? Are you serious? Pop count? What? Just straight up. Okay. I didn't think so. This is why this is fucking stupid stuff. Pop count. It just made it up. I mean, it didn't totally make it up, but it did. It definitely did make it up. It's a proposal. Why would they propose pop count? Oh, what? Okay. Interesting. Wait, is there actually bit array? Closed. Why no? Close as completed. Oh, okay. What do you mean completed? What do you mean completed? Just the code I provided above. What? Get bit? Oh my gosh. I really can't do string stuff. Okay, I'm just gonna make a count bits thing, I guess. So what I want to do is I want to round this well, I guess I get the log 2. Okay, this is there. Bit. How would I use these flags? How would I use this? Bro. Alright, never mind. planes. And okay, I won't do this then. I'll have an explicit array of plane. And just store it there. Though it also doesn't matter which of these planes it is, just that I have no more than 3 of them. And these are the ones that need to be checked. Simply intersect. Intersect segment. Taking one of a segment from position from to 2. You can actually just write inner to outer. If point, then I say E is equal to point, or it would be camera. Project that point. We don't intersect it, which, whatever. The only reason I don't play games with Goonamons is because I would have to play them to Goon. Okay. Thanks for that. Appreciate it. Okay, if planes is 1, we just intersect. Let me just do this. Head of 2. Find the intersection, which is behind the other. If point and this is just kind of weird. Inner. I don't know how to write this better. One of these should be true. But I'm going to handle the other case where it's, possibly not true. Planes one. What is wrong? Oh, is point over. If we have a point, I guess I could do the same thing actually. If not a point, or is over, do this. Take the other plane, intersect. And if I don't have a point, or it's over the other one, we're done. Otherwise, it is just this. Three. It's going to be like this, but way more booleans. If not point or planes 1 or planes 2. At this point, it's probably appropriate to do this. I don't have a point, or it's over that one or over that one. Nest one more time. I tried 2. So if it's not there or for all of those, then we fail. Okay. Otherwise, not logical. I can't imagine a case where it's ahead of 4 planes. That doesn't make any sense. Yeah, if all the planes are at right angles, then this doesn't logically make any sense. Why is this tabbed in an extra 1? Oh yeah, if 1 point is outside. Alright, man. I'll look later. One point is outside. Dude, if those are the words you use, then I'm not going to look on stream. If those are the words you use, I'm not looking on stream. So if it's ahead of... If 1 point is on the outside, but the other one was inside, then I use an intersection logic. Otherwise, both points are outside. Determine if... yeah, sure. Determine if any... I guess determine if the segment intersects. So then what I have to do is I have to say... I have to find the point for S, and I have to find the point for E. So essentially what I do is I go through, for S, I go through every plane until I find the intersection that, until I find an intersection point that is, well, I guess I go through every plane that it's ahead of and intersect and check every other plane in that list to be sure that it's behind it, and then if it is, then I'm successful. I mean, this is probably where it's just like that, because essentially what I'm doing is I'm taking this one and from and to. Okay, I think this is where I probably just at least 1 point is outside. For each point, determine its intersection with the frustum. This is a point intersected on plane A, where all which is behind all other planes. Okay. If this is 0, I'm simply doing that. project start. And then I'm good. Otherwise, I find its projection. And maybe I just make this a function. This. And I guess I'll say if I am unable to find this intersection, then I know I'm done. End to start. End is not finite, do that. Okay. So this is a potential case where essentially I'm just casting array and I'm finding any plane whose intersection point is behind all other planes. So this will just be simplified down. All right. Nice. Finds the point. I guess I actually will just intersect planes instead. And start with E frustum and start with S frustum. Finds the point on intersection point on a plane list which is not over any of the other planes. Okay. Wait, did I do this right? Supposed to be range. Returns an infinite vector. I'll just do those. Okay. So I check, I have this plane, and then I have this plane. So then I say, I intersect on this plane. Actually, point is just going to be... This is supposed to be a variant. If we didn't get a point, we continue. So we have a point. Now I want to go through each of the other planes and check if it's above those. So if planes K is point over true, and I break. Oh, this is really simple. Wow, this is super simple. So this is the intersection point. If it intersects, I grab that point. And then I check if it's... I check the other planes, and if it's not over any of the other planes, then it's definitely in the frustum. Okay, this is good. This is all pretty good. Alright, so this should clamp the segment. And then it returns that. Okay. Not that much code, really. Nice. Though it took me a long time to get there, for sure. What am I at? 2, almost 3 hours? Should start like timers to see. Okay. So I've got a segment. So I want to do draw. I'm going to draw this line. Color. I'll just do blue. Width. Does that even matter? A 2-point primitive will be drawn instead of a 4-point one. Yeah, okay, so I just leave that. Anti-aliased. I would like it to be anti-aliased. Yes, please. Anti-alias that line. So I do this, and then I will ask, well, I guess what I really do is at this point, I then take this, and I want to draw a little arrowhead at the end of that. So what I want to do is I have this vector, I want to find a perpendicular vector. I really just want to find any perpendicular vector. How can I get a perpendicular vector? I would like to get a perpendicular vector in the direction of up. So if I have a segment like this, I want the arrow to go like that. If I have a segment like this, I want the arrow to go like that. So the arrow thing is like pointing towards the up direction. Or pointing towards that vector. Or pointing, if you drew a plane vertically, the point would point up there. I guess, okay, so I guess what I do is I take this vector, I cross it with the forward vector, and that gives me a vector perpendicular to both of these. Right? So should I either point this way, or if it's like this, it'll point. Actually, yeah, it can. I need the right hand rule, right? So this vector cross with this vector points down. This vector cross with this vector points up. This vector cross with this vector points up, so that's the correct way. This vector crossed with this vector points up. So I guess I can say, So if I want to project it to the starting position, so let me do this. I need some math here. I need some variables and I need some math. The screen space, if I'm correct, find in local space. So it's like 0 up here and then it's down like this. So this vector cross with this vector. Okay, so let me think about this one. So this vector cross with that vector. I'm gonna like this. Okay. So I say if the end point is less than the start point, if the end x is less than the start x, then my vector points backwards at me. Or it should be negative z, right? Yep. This is positive z. Yeah. Starting at here. Okay, so then I get a directional vector. If perpendicular is approximately 0, then perpendicular will just be I think it's right, which should be positive on the x. Good. Normalize it. So then now I have a direction. So I want to say draw from the end to the end. I guess I'll say this. If if e dot y is greater than or equal to s dot y, then I want to move up. My perpendicular should be pointing well, yeah, if it's approximately 0, otherwise, oh no. Alright, honestly, I think I just do some normal math here, because I have made this perhaps a bit dumber than it should be. No, because I want to go off here, so this is my up direction. This is my up direction. Cross here, cross with that vector. This is my up direction. And then I have this vector cross with this vector. No, I just go back towards S in that direction. Okay, so this is my perpendicular. This is my down. We have vector 2, which is just the negative of the end minus the start. Yep, it's just the negative of that. I guess I can call this up. So then what I want to say is I want to go zero out the z's. Okay. Yeah. So from E to E plus, this should be normalized. And I guess I say if the length is approximately 0. I can't do anything. So E, the length of this doesn't require, let me say, So I want to clamp it to, I guess actually not. What I really want is back 0 prox. Visually on the screen, I need to prevent this second arrow piece from being longer than the vector is. Or like longer than half the vector, I guess, is really what I should have. I mean, I guess what I could do is actually do another clamp segment. I could take the real vectors and project the point slightly back. I don't know, I'll just draw this. So the arrow, honestly, I think this actually doesn't matter. I should probably draw the full arrow and not just like a half arrow, which is what I kind of want to do. Also, I feel like it doesn't really matter. If the vector's pointing up and I cross with this, will be like that. It'll always point like that direction, sort of. It'll always be to the left of it. Sorry, what I'll really do is I'll just cross it with I guess there's a forward cross with this vector. Oh yeah, okay, let me do that. Then I could just skip the cross vector. And then I set it to 0, and if it's approximately nothing, then I just use the right vector, otherwise I normalize it. Normalize this. E minus S. Which this could be nearly 0. So I guess I can just do that. I just skipped that. Vec2D normalized. Right is this direction. Okay, so I do E plus we'll go right times, I'll say 5. And then the length of this, so is it the 5 pixels or is the length of this one? So small value between 5 and length over 2. So if the visual length of this is like 3 pixels, I don't want to draw a 5 pixel thing. I want to draw like a 1.5 pixel arrow. Okay, so hopefully that will now have me drawing arrows. All right, so let's just track a forward integer. So I have like a debug thing somewhere around here. So export custom. I really wish it would just keep that there. Group enable. Checkbox only. So then I have debug forward. And I can say a forward debug vec. For debug vec will be debug draw vector at my global position in the forward direction for no time, and I'll actually put ID first. What? And then say, like, we'll trace it for 2 seconds. And then it's complaining about, like, some stuff. What was that? What was that? Yeah, I think the IDs being first makes way more sense. Because I may not want to use a time more often than I would like to not use the other one. Alright, cool. Let's see if I can see vectors. I just go here, I go to player, go to debug, turn it on forward, save. Don't die. Okay, it died. It does not like T. On base nil int. Huh? Oh, this is keys. I literally don't care. I do not care. Delete on what? No invalid access to property. Okay. Fine, has delete. Uh-huh. It appears that I cannot see this. One sec. One second. I'm back. I have been given food, so I'm gonna go and eat. Oh, jeez. That's really bright now. But why did it not draw? Why does it not draw? Oh, I guess if I do this and then... Oh, wait. Is it because it draws immediately? No, it's got to draw at the end of the frame, right? Also, this is just supposed to be if it is 0, then I skip it. Alright, so let me do... I guess let me say this. Let me say print. Print. Section with Rustum. Print. Screen size is 0. And otherwise we're definitely drawing something. So I'm going to say print. Drawing segment of segment. Length is 0. That's expected. Try. Oh. What? Why does it not like that? What's here? Okay. It almost works. It almost works. Don't know what's going on there. I'm gonna grab a fork. I'll be back. I was thinking possibly it's running it from a different camera, but the segment's definitely like placed on my player, so it's using the right camera for sure. But I don't understand why it thinks it's stopping for some reason. It's like this one is immediately failing because this should be working every time. The negative 2000 is crazy. What do I have it here? Yeah, is point over. These should be false every time, all the time. That's actually working too. Like somewhere over here, it hits 0. Yeah, this. Oh. I'm in the box. Yeah, that one is weird. Seems correct. What? There's like a whole box out here. What is this? What? Oh, it's different now. There's just a hard line somewhere over here. What? It was over here. Oh, there it is. There's something weird happening for sure. Like the frustum, the frustum. Yeah, it could be not updating. It's possible. Oh, that is it. I'm not updating the frustum every frame. I'm supposed to be updating the frustum. I change the camera, IQ redraw. If I have a camera and its transform is not the same, say last transform equals global transform, I update the frostum, and I do a redraw. And you can see it's clamping to the screen. That arrow. It is a bit weird, but you know, I can kind of see it. I can see what happens here. Oop. Oh. Assign nil to dictionary. Well, if ID is less than 1, I'll just say variant. Yeah. So go on the ramp, and I will. The vector looks correct. Oh, jeez. I mean, the vector does look correct. Why is it? So why is it? Oh my gosh. Wait, it's not shoving me like hard into the ground now. Also, if anything, I should be like bouncing over it. Really. I guess it is maybe a little bit different because... Oh, gosh. Jeez. Also, that vector is huge, by the way. That vector seems way too large. Maybe it's friction or something. But see, the good thing is, I now know my vector appears to be good. I can see it. Can literally see the vector. Let me just set up a camera. Roughly over here. Maybe I should go orthographic. Oh, jeez. um. Okay, just go. Perspective. Just do that. Make that current. And I think it should just process the first one that it finds. So even though I have two of them that are made current, this one will actually be current. Okay, so it didn't work. Alright. Gotta go player. Uncheck that. So I just hit forward and backwards, and I can see the vectors. Yeah, so it looks good. Something else is definitely happening. Let me throw these prints off. I've got it fixed. I was simply not updating the frustum. Very cool. Okay. And then I guess I need to make it so I can draw different colors too, so there's that. Okay, so now I must provide a color. What is this warning? Narrowing conversion, float converts to int. It's converting the float to an integer color. That's hilarious. I don't know why I would try to do that. I feel like I probably shouldn't try to do that. Green, yellow. Also, debug normal. Actually, if I really think about this, this has been a thought. So, if I treat the spring as being like attached to the ground, the spring can pull back. That gives me my step down ability. Sort of. So I should definitely set it up that the spring has me off the ground by like, I don't know, 20 centimeters or something. And then I have the height offset be 20. And also I'm gonna have an add too. Because typing in negative 0.3 to raise it 0.3 sounds weird. I should be adding this offset, not subtracting it. All right. I will be right back. I am back. Okay. What did I say I need to do? I need to make this... Okay. Got that for now. I should make this extend slightly. A little bit further than normal. Or a little bit further than just straight down. So if 37 is where the feet are, let's do minus that, sure. And then my rest length will be height offset negative 0.1. So I sit 10 centimeters lower. My rest length is 10 centimeters less than that. So on character controller, this becomes a plus. And now I see what this does. Also, so spring, I'm going to name this spring now instead of, okay. I guess it's called spring force. So spring force will become this. This can actually be, this can be a negative value now, so I don't need to clamp it. Normal with the spring direction. Okay, so I have some directions here. Body state apply. Okay. Let me call it push, and I'll make one called pull. So I can pull myself down. Well, I guess I can't really pull myself down. Alright. It's only going to be a push. But I can still have like a damp effect on there too. Huh? Because the way I think of it is that you only push up and you have some power in your legs, right? But to fall, it's really just you. Yeah, you know what? Never mind. Just leave it called push. I'll just move it back up. I'm not going to have that. I'll just have a plus and I'll make it negative 0.3. Or, yeah, I'll try to sit 0.3 centimeters higher. And then this will just go, yeah, I'm just going to go back to normal. We're going to say the spring is not stuck onto the ground. So just do that. Okay. Also, honestly, let me put the camera like up to the ground so I can maybe see how. Oh, jeez. How well aligned the player is. Okay. There's also a lot of shaking. So I need more damping is what that really means. was like, where are my settings? Here they are. Four? Okay, can I put the player a little bit further forward? So it should look like that. Wait, did that stabilize like right away? It is always moving a little bit. Is this really not doing anything, by the way? I feel like I'm raising it so far that... Yeah, okay, there we go. Now we've gone into something weird. Oh, that's like right there. Alright, but... Okay, I'll go down to this. Yeah, let me see this, and then let me... Right, increase the damping slightly. What just happened? Why did that... Literally, why did that happen? What the heck? It went full screen there for some reason. Oh my god. Let's go back this way. Uh-oh. There I am. Why am I rotated? Why have I been... How did I get... Wait, am I moving? Oh gosh, I'm moving around. I didn't think that would happen. Pretty stable. Maybe I raise the damping a little bit more though. Okay, what if I just make it really high? Is this not updating here? Okay, it is updating there. There is a motion that I would like this motion to decay to nothing. I would like this to actually just become totally stable and not moving. But it's moving slightly all the time. So what is it doing? Because apparently some of these forces are changing. Right, I'm applying some kind of linear velocity. I guess I can just print it and see what it's doing. Alright, I guess I can say if it's less than 1/10 of a centimeter, then I freeze, right? So let's look at the very first thing. The very first frame, I have quite a lot of fall, right? Let me see, okay, what is a single frame of 9.8 meters per second, or 9.81? So 9.81 times Why is it so much higher than the first frame? So I want this value, 2.5 e negative 5. Do this. Awesome. So this will mean this will allow the camera to be totally still when you're not moving and you're stable. Okay. All right, now I just need more debug stuff. So now I want like the normal force, the normal direction. This is actually going to be the intersection. Shape cast out, get collision point. Did I already save that normal? I do save it, so this can just be called normal. I would like a fire brick. Normal debug vac. 2 seconds. And then friction. All right, let me write all these out. Friction is actually applied at my position. It's not like a normal. I want to see that, so I'll just say global position. You know what? I'll actually just do... Oh, yeah, let me say global position plus... half meter up. with the friction vector. Let me make this one fire brick and the other one will be blue. It's cornflower blue. Turn it all on. Interesting. Okay. Let's take this off. Well, maybe I just fix it and make it higher up. So it's slightly... Oh, no. Oh, no. That position, but with just negative friction. I don't... That was my mistake. I'll move my mouse slightly, so... Alright, so friction is not... applying correctly. I thought it would already be rotating, but I guess it's not. Yes, I'm not really sure what's pushing me, what's like pulling me into the ground, but something is kind of pulling me into the ground. Let me just do like debug velocity as well. Oh, yeah. I mean, I think I can just write normalize. Alright, never mind. I'm just gonna leave it simple. Regular at the end. I guess this would be some kind of green. I'll just do that as 0. And of course I didn't turn it on. All right. Now here's what I'm gonna do. I'm gonna have a global. What? Let me do this. Let me change one of these keybinds around. I want to be able to change my world speed as I run. So I'm going to change around. That one. This will be resource action set game speed. So I'll have a couple of these. Shift 1 will set speed to 1. Shift 2 will set speed to half. So let's do a scale 0.5. Shift 3 we'll set it to quarter speed. That's all I'll do for now. These will just be unpressed. Okay. So now I can go to my input manager. Then I say if I need set game speed action. Right, like that, yeah. Value access 1D. And I guess just to be safe, I'll clamp this to that range. So I'm gonna do 1.5 speed. Okay, or not. Oh. Huh? It's just not doing it. Did it not save? Why? I'm assuming it's just straight up not saving this thing. So, save. Reload project. That's the only explanation, is that it just straight up wasn't saving it. It's there. It's not doing it. It's just not doing it. Okay, so what's your problem? Shift 2 and Shift 3 aren't doing anything. They're literally not printing. So why? Why are you not printing? What's the problem? It's because it's a Boolean. Stupid. It's still only processing. Explain. Explain. Explain how this makes any sense. Why are these being rejected? These just aren't happening. What? Why? Why are these not applying? The hell? Okay, what if I put that one up top? What do you think about that one? One is still the only one that does anything. Okay. Why? What? Okay, I'm gonna delete the scale modifier. Now 2 works. Okay, so adding the scale modifier breaks it? This breaks it. It can't handle that. Okay. So I think that's just stupid that this doesn't work. I think it's completely stupid. If I have a Boolean input, it should definitely still work. Let's go edit this script. What do you think? If it's not finite, return that. Like, huh? Huh? What's your issue? Value x equals 1 if is actuated, else 0. What if I just did this? What if I actually just printed it up here all the time? Because that doesn't make any sense to me. Okay, so it is working. Is triggered. What? Pressed. Oh, are you serious? I know exactly what it is. This pressed thing has some actuation threshold, but I happen to know that it's a key. I guess I can just do one. Seems like I have a mistake with timescale. So about that far in the ground. Yeah, I'm twice as far into the ground, so I have a mistake with step or something. Oh, am I supposed to be multiplying it by times by engine or something? Yeah, just do that. Okay, so it's correct. It is correct, actually. That got cut in half. So something around here I'm meant to be using as step, and I'm not. Because I'm seeing myself drop into the ground about twice as far as normal. These should be multiplied by step, I think. That's possibly it. Okay, so let me just do this plus all of these. All of that combined. That's weird. I mean, debug tools for the win, I guess. Friction is ground velocity times the smaller value between what? What was this trying to be? If I exceed 1, I don't exceed 1 any further than that. Okay. Mistake times 1.2. Interesting. I'm actually not sure why. Why is my velocity still like really low? My friction is low. So my Ford is on the ground, right? Yeah, that's my Ford on the ground. Why is it not dropping? My friction is lower than my velocity now. So my ground velocity is not correct. I do have, I mean, I obviously have this contact here. I take the contact velocity minus the vertical velocity, which is my basis times the dot of my basis with that velocity, which is actually just 0. So in fact, ground velocity is just my linear velocity minus my current velocity minus the vertical component of my velocity. In fact, I don't know why I'm doing this because this is just times 1. Oh, well, I guess I have to do that, yeah. Yes, ground velocity. I don't understand. I have the step correct now. You know, I'm doing everything by step. Gravity plus the push force plus my forward force plus my, or minus my friction force. It is actually a bit incorrect, though. This is meant to be... Yeah, this should just be my ground velocity. No. Yeah, not. Okay. Friction will add ground direction times smaller value between ground speed times or nothing, and I'll just say 1. Two, and I multiply this by 2. Why are you not happy with this? What's the problem? Unassigned variable not previously initialized? Oh, sure. Let's say if I want to move, I'll just say friction is, technically it's just like airspeed, so it's really just a small so yeah, let's just say it's like some kind of airspeed thing. So if I want to move, air drag only. If I don't, then I have stop quickly. Um, I think I kind of have this a little bit here. Nope. This file. It's kind of just like, I did have this preparation for fluid stuff, but I don't think I'm gonna have any water. I think that was also meant for like air. Yeah, like dragon air. Go to the bottom here. Somewhere up here I have some kind of friction thing. It was only on ground, it wasn't even doing any air stuff. Oh, here it is. Compute drag. Density and area. Move drag. What? Air resistance. So it'd only be 0.5 times drag times density times area times negative velocity times velocity. Right. I'm gonna go to YouTube for this one. One half p velocity squared. Drag coefficient A area. Is that half density? What? 1/2 density times. I mean, yeah, if that's correct, 1/2 density technically times the drag coefficient times the surface area times the velocity squared. And that negative velocity times velocity absolute is just to keep it in the same direction. Okay, sure. One half. Not fast enough to hit the mute button. I can hear him start growling. And I'm like, oh, I gotta mute. Alright, so density. I don't know what. I have like some coefficients up here. Densities. Some densities up here. $1.21. Times density times the drag coefficient times velocity squared, right? What is the drag coefficient of? Just going to look it up. Whoops. So it looks like what? Should open with Firefox. Oh wow, look at this. I found it. I found a study, a paper written on this. There's a drag force, and then they just regrained for coefficient of drag, which I guess they know these values. Wait, what? Why is coefficient of drag on the bottom? That can't be right. Yeah, what? Did they make a mistake there? I don't think they're supposed to write CD on both sides of the equation there. But sure, whatever. Okay, so they just did some measurements. Results. The pressure component in the viscous the drag coefficients, pressure, viscous, and total. Drag. Pressure and viscous. Huh? I didn't even know those are different things. Possible that the drag coefficient was prone to firstly drop and afterwards raised and kept reasonably constant to 0.7. Pressure component, the viscous component, in the walking direction, the total drag coefficient. The drag coefficient is decreased with velocity because we just go into a better posture, I guess. Okay, so it seems like it trends to 0.6 or 0.65. So I'll just say 0.65 for my guy. So area, the cross-sectional area, do they have any measurements on that, the cross-sectional area? The cyclist geometry was at 2.5 meters. Huh? Eight years of background in running. That's so silly, by the way. 8 years of background in running. How long have you been running for? Dude, since you could walk. Like what? Since you could walk. What did they determine was his cross-sectional area, though? You need the area. The area is part of that. Okay, you can't just write the same formula twice with literally not a single letter different and say they're different form. This thing's definitely got mistakes. I'm so confused. dv is equal to drag that like what did you measure? Area. Oh, here we go. The authors presented a drag area for one runner of 0.272 meters squared. Assuming this drag area for the current study really? Surface area. Okay, so they literally like 3D scanned this guy or whatever, and they didn't measure his surface area. Yeah, well. Where's the assumption? The provided projected surface area of the participant's 3D model. Are you kidding me? They're literally saying projected surface area, and then they... In another study, Simmons drag for the current study. Like, what was your... What? Okay, so there is in like 0.272 square meters, okay? So like a small, like... I mean, I guess I can compute it from theirs, though I don't know why they don't just give it. Can I just copy like this meter squared thing? Yeah, they literally just don't give it. Why don't they give that? I'm just going to say 0.3. Stop quickly so I compute a speed and a ground direction. And then I'm going to say, let's stop. Honestly, I'm just going to say ground direction. I mean, ground velocity normalized. If wants move, ground velocity is not 0. Stop quickly. I don't even need that. So just do ground direction, and I'm gonna say apply the smaller value between 10 times my so if I have a direction and I say it's 1 multiplied by step, this is a deceleration of 1 meter per second. Okay. I mean, honestly, let me just start with this. Air drag. If not wants move and I have ground velocity, then I'm in contact with the ground and I can stop. I have a relative ground velocity. So let's just add just ground direction times 8, right? Okay, weird. Right, so it does need to be ground direction times 8, but then it needs to be limited such that this value times step. Yeah, so I can just say this. The smaller value between this and yeah, I think just ground velocity over state dot step. So if my ground speed is like 2 meters per second, I want to decelerate. Okay, so I have an acceleration, all right? So my current deceleration, I'm saying, or my current acceleration as friction is 8 meters per second in the direction of my ground motion. Just 8 meters per second, let's just say forward. 8 meters per second forward versus ground speed, which could be 4. So it's 4 meters per second over this step. Or I guess time step. Actually, it should be, yeah, it should just be time step. So if my ground speed is 4 meters per second, and I'm going to take, all right, let's just say, yeah, over the next second of time, I want to remove 8 meters per second from my velocity. So, or I have a constant stopping power. Oh my gosh, whatever. This is so weird to think about. I'm just going to run with this, and I think this works. I'm just going to see if this works. Okay, and I never stop. Okay. I guess it's actually just meant to be ground speed, right? Okay, but I slide. So it's still like not quite correct. So then I was thinking over step, state, step. Am I like detaching from the ground? Is that what's happening? I'd bounce. Oops. Oh my gosh, did I rotate? What? No, okay, I'm good. Oh, that's what I thought. Okay. Let me go stationary. Okay. I was correct. The overstep. My gosh. I do see the normal change, which leads me to believe that I'm detaching from the ground. Okay. Let's go back to 0.3. And I'll just do 0.3. And then I'll just have better friction stuff for motion in that direction. But yeah, okay, cool. Stopping power is perfect. In fact, I might have even been like kind of doing a bit too much with that estimation there, and I probably could have just said to look at this. Compute friction. What is this? Wish direction, turn rate, keep. Keep is turn rate. So friction is my friction power, direction is my current direction, my wish direction. This is just a orientation and a power, I guess. So this stuff will be good to have. Then I look here, ground velocity delta. Exactly. Negative ground velocity over delta. Negative ground direction times friction. If ground speed is greater than 1, if stationary, ground speed is greater than 1. Okay, so yeah, you stop slower when you have a lot of speed. Otherwise, it's negative ground velocity over delta, which is exactly what I do here. Ground direction times ground speed over delta. But the smaller value between these two. So I guess I can say yeah, let me see. Let's go to quarter speed. Start accelerating. Stop. This is interesting because I'm not really seeing this. This is a very different calculation. This is a velocity over delta when I'm stationary. Here I'm doing a speed over delta. I'm doing it like this. Which I guess this is just one, then I just treat this as the velocity. It's just a one-dimensional velocity. Speed. Okay. So what is this? When this is like... Yeah, I mean, when it's just really, really small. We use this one. So what this means is I'm either stopping at 8 meters per second. I guess this gives me a good stopping value, right? This is like my stop value. I'm a little curious though. I would like to attach the camera to the player here and then center it like this. Nope, that's 9. 0. Somehow have a side-scrolling game. And I've rotated the player slightly because I'm dumb. I think I just did it again. Alright, so my velocity has peaked. It's not getting... Oh, and I fell. Okay. Alright. That was interesting. What? Show me that again. I was able to jump up that, really? Interesting. Oh, that's really cool. There's so you can see like the centripetal force as the red line right now. It's perpendicular to my velocity, pretty much. That's cool. So I'm trying to remember. All right. Oh, I fell off. Whoa, 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 whoa. All right, this is pretty cool though. I do fall down a little bit though. Perhaps what I can do is I mean, I think it's a thing where I should walk into the surfaces slightly. That's an idea. Can I walk up these other ramps? I mean, I guess I'm really only limited by gravity, I think, because gravity will pull me down. Yeah, I feel like I might be able to walk up walls. Alright, let's go to slow. Yeah, it looks like I'm kind of pushing into the walls. What's happening, right? Alright, I am pushing into the ground when I walk over it. Yeah, so the friction vector doesn't look correct. The friction is not really... Yeah, what happens at the start? Let me pay close attention to what happens at the start here, when I start to move. I'll let it settle. My vector is off the ground. It does actually start off the ground. Because my desired direction is that yellow one. My true velocity is the green. So yeah, it starts with a bit of an off. It starts more than it should be. Also, it's really weird that the friction vector is he's like coughing now because he's been barking so much. Okay. Yeah, this is a weird thing. I start seeing a friction that's just straight vertical, which is wrong. That force shouldn't be happening, right? Maybe, I guess it is, I mean, I guess this is technically air drag, so I'm just gonna take this off and see if, yeah, I mean, that's like air drag. That is the air drag applying. I mean, I guess I should probably actually interpolate this area to my actual direction of motion. So if the majority of my motion is lateral, it's, I guess, just dot with the up vector. I get my vertical speed. Yeah, I think I need to do like some kind of interpolation here. So have a linear velocity length anywhere? I mean, I guess I can just compute it here. Yeah, it should be my basis, actually. Don't I do this? Somewhere? And then this is going to be mad about this. Linear velocity minus vertical velocity. If it's a rear body, then I have to consider that one's motion. From, and then two, just gonna do some check here. What? I'll approximate that as a sphere. I don't know how to do this. Area of circle. Okay. So circumference is 2 pi r. That's not right. What? It is 2 pi r. Okay. I forgot math, I guess. One, two. So 2 pi r squared. .09. And then coefficient of drag of a sphere. Of a tube. I'll just let me search capsule. Dude. Stop. Stop. What did I even agree to? How did I get anything? I mean, yeah, it'll just be like this, right? Skydiver. But not like this. I'm like this. I want this. Hmm. 300. So I can think of this as the point at which your acceleration due to gravity is equal to your deceleration due to drag. So if they say 300 miles per hour, pH 2 meters per second. 300. 134 meters per second. And the force of acceleration is equal to the force of gravity is equal to the force of drag. I just don't know what to do with this now. So I'll just round this up to 135. Where is it? There we go. 135 meters per second results in a force equal to 9.8 meters per second squared. Deceleration, yeah. Does this just mean I plug this into here? Because what I'm trying to compute here is this drag coefficient here at the front. Okay, stop with you really wanting me to type acceleration in there. That's just, please stop. Stop that. Okay. So I can just treat velocity as a speed, by the way. So I do 0.5 times. So I'm essentially saying 135 meters per second is equal to 5 times 1.21. It's not full screen, so I can like times linear velocity, which is the exact same value. Oh no, this is 135. That's my velocity times 0.09 times my area, which is now unknown. Right? Doubling between... No, this is my area, and I know it. This is my drag coefficient. So this is C. Okay, so if I just math this out, all right, so I have this value. Zero 0.01. All right, say 0.01. Bilateral ratio. So when this is nearly 0. Oh. Wrong way around. So when this is nearly 0, or I guess if it is 0, that's fine. Nearly 0, I guess I say linear speed. I'll just say this. This is not approximately 0 that I can do drag. So as this becomes the dominant factor, we use that. Clamp this value between 0 and 1. Okay. Now hopefully a correct air drag. Right, so I'm not seeing that weird this thing appear anymore when I'm just bouncing up and down. So yeah, forward, it goes into the ground a little bit too much. Backward. Forward, it goes into the ground. Backward, it comes off the ground. Yeah, it's weird. It's really weird. In fact, there's above my desired motion for some reason. Which I guess is not too bad. Though possibly this is the point at which I would maybe I do need to make this extend down a little bit and then use a positive height offset. Let me do this. I'd like to understand why this seems to be pulling back a bit. There's the application of gravity here. So, which I guess isn't really needed It kind of is when I land, because then I have to settle in the spring effect, right? Otherwise, I'm just never going to like properly settle down. So maybe just when I move, I add or I subtract gravity's effect on that desire for motion. That could be an idea. Let me try this. Let me try... Let me try that. Let me then subtract gravity from my motion. Okay, I just like jump off the ground constantly. Interesting. Very interesting. Yeah, I don't know. I instantly just don't know what to do about that. Because I add total gravity and then I add forward. So if my forward is taking off gravity. I mean, I guess that's just a push, right? The spring is constantly pushing, so the spring should be handling that. Okay, dog's gotta go out. I'll be back in a minute. I'm back. Here's my thought while I was away. I mean, it feels just so obvious when I actually go to say it, but the spring, of course, right? I walk forward, I'm walking up the ground, but at the same time I'm being pulled into the ground. So when I do that, the spring compresses, right? Which I guess is fine for the spring to compress, because then I push up a little bit, but then I move more into the ground, so I kind of reach an equilibrium there. But when I go down, no matter what happens, I mean, that's the part that's weird too. The spring should be decompressing, which means I'm moving down, but that also doesn't make sense because I'm moving down since I'm moving into the ground still, so the spring should still be getting compressed. Either way I move, the spring is getting compressed because I'm either walking up against gravity, so ground, I apply this motion, but I'm being pulled slightly into it, so my vector should look like that. Down, my vector looks like this, but it looks a little bit more like that because I'm moving into the ground. So why is it that immediately the first thing that happens is let me do this. Let me look at this in super slow motion. In fact, let me get closer. Bring the camera a little bit closer. A little bit down. Okay. Quarter speed. Okay. I'm looking at this. It definitely goes out. Okay, 100% this is going out for some reason. So let me see. I mean, just the the forward is correct, right? Like I'm only, this is my forward direction. Forward normalized. I definitely have forced ground movement enabled, by the way. Definitely I have this enabled. 100% it's turned on. 100% it's turned on. In fact, I can't even turn it off. It's forced on. Okay. All right, let me do this. Let me do angle to my Y crossed with the ground. Huh? Okay, hang on. Up, cross my desired direction, I get a normal direction. normal. This cross with my normal gets me this is the same thing, right? How was I not running into this problem when I was doing it? Up direction, cross with my move it direction, cross with my normal direction, normalize. Minimum angle. Up, cross with desired direction gives me this vector. This vector, cross with my normal, gets me like the back direction, which is weird. Why do I get the backwards direction? Ow. Okay, so why do I not understand the right hand rule? My up vector, cross with my desired direction forward, gets me this vector. Now I take this vector, cross with my floor normal, gets me a vector pointing the wrong way. How does that work? Did they even mention the right hand rule? This is correct, right? By the right-handed coordinate system. This is my right hand. If two vectors are parallel. Oh, wait, the normal points down. The normal points down. Right. Okay. Up vector, cross with my desired direction gets me this vector. I take this vector, cross with my normal vector, and I get my forward vector. Now it makes sense. Okay. So the forward angle to oh, actually I want to print you know what, let me just draw this vector slightly above myself or something. Let me just do that. .5 for friction. Let's actually do 4 for friction. Let's do forward half a meter up, and then velocity above that. Okay. So now these will appear closer together in space. Whoa, I'm flying. Okay. Slow speed. Like 5.5 and 4.5. Whoa. Make these a little bit closer together. What if I also visualize the spring? Let's duplicate the spring force. This is a change in velocity, which is actually push times inverse mass. Let's go with like a light purple color. And just keep it drawn forever, I guess. Oh, and then I have to turn it on, actually. Let me actually do shapecast dot global position. I can literally never see it. Perhaps I just do state. I can also multiply by that. Yeah, but it changes scale with time speed, so. Okay. Just divided by 50, I guess. Whatever. Yeah, I cannot see this moving, like, at all. I'll just do over 10. Oh, there we go. Now I can see it kind of moving. Okay, so it's pushing up less because it's expanding. Wait. It's pushing up more because it's compressing. Hang on. It's like right on the shadow. Okay, so going back, it's compressing. And then it expands. That's where it was left, apparently. Forward, expanding. What? Can we be legit? Alright, so it looks like there I started skipping or something. There's a weird jitter happening. I mean, if I look at the vector, it immediately starts not in line with that. It starts going up. So I don't know, my thought was like I could possibly take this and alright, here's kind of what I don't really get though. These two end up equalizing, right? Maybe that's what I should do. Maybe I should do this over that. And this becomes the spring force. This plus that. So I can see gravity over this. So when it's pushing down, it means gravity is stronger. When it's pushing up, it means I'm pushing up. So I'm pushing up, and then I'm pushing down. This is just, it's weird. It fluctuates like crazy. Which is probably just like, you know, spring problem, right? Let's go over here. And I went off the edge. Okay, well. My fault, I guess. What is that? Vectors. I'm looking at vectors. Purple is like my spring force. It's my spring versus gravity force. So when I do this, it's pushing up. That's why it looks like that. And then I detach from the ground. So why would he making? I'm just looking at the forces of the spring, really. The spring is either wrong or I need to incorporate some kind of let me try this. Let me disable this and see what result we get. Because ideally this should decay to 0, but it's not. Right, it's always flickering. That's what I was trying to get rid of with stuff. Okay. I'm gonna wait till it like points up and then I'm gonna go forward. Okay, so my vector's going into the ground. It looks correct. I'm gonna wait till it points up and I'm gonna back up. Okay, we've detached from the ground. Okay. And then I skip. Okay, so it's not that. Though, maybe I can make this number a little bit smaller. That's really 1.6. Hey Davies, unofficial son. Let's try one. Was that to the 6? Nope. It's a little bit better. Like, I still stabilized and stopped. It's a very large vector, though. What are you working on? I am working on the character controller. Particularly around steep slopes. I want to see if I can make it so he won't detach from the ground on his own. Going up is fine. I won't bounce off the ground. But going down, this green vector will point above. It'll be lifted up from the other one, right? And this is causing me to come off from the ground, and then I just keep bouncing down. I don't want to use any kind of step down teleportation to fix that. I just think I should be able to go on a slope without flying off of it. I think there should be just a stable direction that I can push myself into. Like maybe I remove some vertical push force when I'm going down. Because I guess the idea is you don't want to push off the ground when you're going downhill. And maybe when you're going uphill, you want to push more off the ground. Because it also looks like it goes way too far into the ground. Could I actually do that? Maybe that would work. I can reduce my push force by what I'm expecting to travel down or up already. That's friction. Here. So I can take this vector. Well, I probably want to keep the speed there too. Let me try this. Adjust push force according to expected vertical travel. So if I'm going up, I want to push a little bit more. If I'm going down, I want to push less. It does happen to be that dot products will give me a negative or positive value. If I have a vector, if I have my up vector and my slope vector are perpendicular, I get 0. If my forward vector is in this direction, I get a positive value. If it's negative, I get a negative value. So I'm going down, I want to push less. If I'm going up, I want to push more. So push could just be, and this is a force, so I would need to say multiply it by its mass. Yeah. Guess I just try this. And since this one's normalized, this result can scale to a higher value or not. So then I just do times mass. And now I'll see what happens. What are you upset about? Oh, push is a vector. What are you upset about? Ah. That, of course. Okay. This stupid thing. Oh, why was this open? I really want to know why that keeps bugging out. This keeps happening, where it says, oh, this is null. That's not, I don't know if that's possible. Okay, so doing this should just do nothing, right? It's pretty much perpendicular. I go forward. That looks good. If I go back, oh wait, I think I just skipped, but that might have been maybe letting go of the button, I'm not sure. Steeper slope. I'll settle. bouncing still. Um, well, I guess this is actually meant to be expected vertical travel. No. Okay, it didn't solve it. It didn't really seem to make it any better at all. This can be that let me print this out and see what the I want to know what this value is. I'm gonna move the player. Over here. Up there. Two. It's pretty steady. It's a very precise value. Why 2 that? Doesn't seem like what I expected to see. Desired velocity, desired speed. I was thinking this comes in as what do I provide it as? Times 4. Times 4. I believe that's a 45-degree ramp, right? I believe that's a 45-degree ramp. No. Well, a 30-degree ramp, which happens to be 0.5. So 0.5 times 4 is roughly 2. Okay. So that's where that number comes from. So when I say I want to move my mass at this velocity, but this isn't really that. This should be forward normalized. Yeah, this should probably be forward normalized. And then that speed is actually going to be gravity's force. Okay. And now I'm like really jumping off the ground. All right, so subtracting because we're doing gravity. Of course, right, okay. It almost works, but then I just start skipping, right? It almost works, and then I start skipping anyway. I see it start correct. It starts good. I tried to push up a little bit. All right, so I think it may be the case that my spring is wrong again. It's pushing up that whole time. When I go forward, it somehow... It's stable. Which I guess... I mean, I guess it makes sense because I'm accelerating up. Okay, let me make this 30-degree ramp a lot longer. Actually, let me just make the 45-degree ramp a lot longer. Put the player in front of that. So I can travel long enough that I should be able to reach top speed or whatever. And stop accelerating. The acceleration's probably throwing it off. A bit. That looks like square root of 2 over 2 to me. Alright, so we're constantly pulling into the ground. But it's stable. Ooh, and okay, well. Let me put a wall up there so I don't do that again. I guess I just will duplicate this. Colliders that share a floor and a wall are buggy, so I can't do those. And I'm moving the wrong thing. Oh, this is already like wrong. Whatever. Reset. I've got a stop wall. So the down means it's pushing me into the ground, which is wrong. I should be pushing up right now. I think what this means is that it's... Okay, so yeah, let me... I'll just print it out. Just print this. I don't need to see this. This number is definitely correct. So I'm pushing it, huh? I'm pushing up at 6.8. so confused. Do I not understand what push is doing? Push is always supposed to be an upward force. Right. Okay. Oh, it's when it's less than gravity that I... Okay. Print the whole thing out. It's when it's less than gravity. This is the overall motion that I'm making. So it hits -3 there really, really quickly, which doesn't make sense to me. I don't know how it's hitting negative, how it's getting stuck like that. I mean, maybe it's just the, maybe it actually is just that the spring is not stiff enough, right? It's not enough force to keep me off the ground when I'm going up a hill. That could just literally be it. It's underpowered. Let's try 1.8 then. Okay, it's still... Okay, let's print the offset. Because I'm assuming this hits its maximum value. Like a big negative value. Or I guess a big positive value. Okay, that's the value that I'm used to seeing. So the spring can't push me up here. I'm accelerating up at some speed. Okay. Let me just 10x that. And then I'm going to see if this is another possible mistake where my velocity is preventing this from, more damping, is preventing me from keeping myself off the ground. Okay, a bit more damping. Nine. Maybe need higher damping for this now. Okay, apparently damping is not... What? Okay, now I'm gaining... Alright. Okay. Let me just make it 8. Okay, maybe 10's just a bit too high. Whatever. I'm just gonna go with this. Okay, it's still slowly bottoming out. What if it did this? shooting off the ground. I'm so confused. I think it's definitely a problem with the spring stuff. Thanks for following, Mikey1SDF. Alright, let me go get on the platform, because I thought I fixed this on the platform. And maybe what is, I don't know, maybe it's just not going up enough either. Because if I'm reset. Mikey for sure, hello from Kentucky. Yeah, thanks for following. Hello. Okay, let me get to the elevator. And see what happens here. I'm stable here. Yeah, see, this is what the spring is doing, right? So it seems like this is definitely a problem with the spring on a rotated surface. There's no, I don't think I'm accelerating up faster than that elevator is. Maybe I am. Whoa, okay. Oh my gosh. This thing is way too drifty. I think it is a problem with the slope. The spring on a slope. Yeah, you know what? Because if I'm... Okay, I'm just gonna do this. I'm just gonna make it longer and then... about 5 degrees. Close enough. Alright, get over here. There's no way I'm accelerating up. And plus my vector is pushing me up too. So it's not like the ground is accelerating up into me. I'm accelerating up. If anything, the spring should be just staying the same. But if you watch, it's slowly compressing. That number is climbing up. It's slowly compressing the spring. Which maybe this is just... because that was a problem here. There was a problem here that I had to fix. So what if there's a problem here that I need to fix? There's a mistake with... So this is a calculation up here. Spring velocity is linear velocity minus the contact velocity. Dotting with that. There's no contact velocity here. Damp is the exact same number. Spring is just computed up top. Body contact velocity. Spring velocity. What if this should be relative to the surface? So if I'm on a normal plane like this, the spring velocity should be lower. It's gotta be this. It's gotta be this. Because this is the damping. Because I subtract this velocity. If it's moving up and I'm moving up, no spring velocity, right? If I'm moving up and the ground is moving up with me, no spring velocity. So maybe this should be, maybe what I need to have is like, I have my normal. This is the spring's velocity. If the ground is perfectly up, all of my vertical is into the ground. If the ground is like this, part of my vertical is into the ground. Only part of it. If the ground was like this and I'm moving down, it's actually 0 because I'm not pushing any force into the ground. So is this also just another dot? Projecting my linear velocity onto the ground normal. So this should be linear velocity times so if these are aligned, it's 1. If these are like this, it's 0. And this should just be clamped, I think. Or I guess I'll just do clamp. Is that the solution there? It's still slowly compressing. What I'm doing there is the equivalent of the ground pushing up with me, and I am now accelerating with the ground, right? So why did that not work? This is effectively me projecting my linear velocity. No, it should actually be multiplied by. No, that is right. That is right. Should this be dot with the... Is spring velocity... Linear velocity times spring direction dot normal. What do I say spring velocity is that? I guess this is linear. No? I'm so confused. Spring direction dot with the normal. Multiplied by... I mean, maybe it is just this. Multiply these terms together. It's still slowly compressing. This is exactly what I saw when it was moving up on an elevator. Should I do linear velocity dot the normal? It's not compressing. It's not compressing. It's not compressing. It's not compressing. It's staying very close to the same value. Down. It's not compressing or decompressing. Wow. Is that it? On the ground, it should just be just totally normal, like unchanged. Okay, and then I start. Oh, wow. Let's go full speed right up the 45 degree, which is gotta be this one. Oh my gosh. Whoa. Yeah, I launched there. Now down, no bouncing. That was it. That was the math I was missing. Yes. Yes. Now it does do this weird thing where I start going forward. It is still a bit bouncy, which... I mean, that's probably just like damping a little bit. Maybe a little bit more damping would help that. But that's it. It's spring direction dot the normal, linear velocity dot the normal. And this is my spring velocity. This is a correct calculation. It looks correct to me. The value is staying really close to be this, really, the compression. This is the length of the, whatever. It's staying very close to what it is on flat ground when going up inclines. Awesome. Yeah, I think there was a thing where... Wait, did I like hit the wall and launch up in the air? Yeah, that's just kind of crazy. I don't know why I launched like that. I don't know, maybe that's just what would happen if you were to run straight into a wall up a ramp. I don't know. Yes, it was the spring. Yeah, definitely more damping, I think. Definitely a little bit more. I think I wrote it with more or something. The stopping up is maybe weird. Yeah, I mean, that's pretty... Hmm. Did it just go down? I think I had some different values at some point that were probably a bit better. It was like, let me go see. They were committed previously. Player? What? Because I have 1 and 2 there, but I think I have like 2 point something instead on player. 2.4, 2.7. Let me try those values. Let me see what that looks like. All right, let me jump off the edge and see from here. Pretty good. Let's go up this. I do bounce a lot though, so perhaps maybe like still, you know, not more, but just more damping. I don't know. Let's run this at full speed. I mean, it feels interesting, the bouncing. I also definitely have a case where I should not be able to run that fast up a hill. That's kind of impossible physically because you're pushing up your whole weight. And that takes a lot of energy that your body just cannot produce. That's kind of whatever, you know, that's whatever. Let me jump off here. All right, damping, let's just go like 1.8. Let's go a bit higher, but not too high. Let me jump off this edge. It was basically a land and then no bounce. Jump, 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 jump. All right. I'm good with 1.5 on 1.8. I'm happy with that. Bouncing on it. But he's not though. It's like a, and then he settles. I gotta make it brighter in here 1 second. I hope that sound doesn't go through. That's like just a crazy sound. that my blinds make. Okay. That's a big fix. That's actually just so huge. That has been bugging me, and it's fixed now. I have debug stuff. Oh, I'm on a roll. I'm actually just on a roll. All right. Get add Godot game. Well, I guess I should add steps just to see what that does. So I'll make... this is going to be like a ramp wall. Box. I'll just call it a wall. Also, there's kind of an absorption thing, right? Am I missing that? Maybe I'm missing that. Because there's part of the physics of material is absorbent. Subtracts the bounciness from the colliding object's bounciness instead of adding it. Should I make it like absorbent and then 0.2 and see if that affects how I slam into the wall at the top of the ramp? Because it is crazy that I can just run straight into that and launch. I feel like if I were to hit that anyway, I should not launch. Maybe, I don't know, maybe that's just not... Whatever. Forget it. Okay, but I do think this should probably be a little bit of value, so I'll just make this like 0.2. Maybe that'll help me not fly up the thing when I hit it. Okay, it helps a little bit. I mean, I guess if I think about like the actual friction of... I'm gonna look this up. Alright, never mind. I didn't find anything. I'll just make it a little bit larger. Because if I think about what you're wearing, you know, you're like in clothes. Okay, you're not actually in clothes. But just a body, right? Hitting a wall, like surely that doesn't just send you flying. But then, and then there's also the case that like you can't just run straight up a wall like that, or straight up a whatever like that. I may also be launching as part of... Alright, let me go slow motion. I may also be launching just because I hit the wall, and then before I release the key, I like get a frame or two of walking up the wall. Okay, that was full speed. Okay, so I'm guessing there is like a slope thing where I hit that edge and I had like a full velocity straight up in the air. Why don't you make a Minecraft clone in assembly? Isn't everything in assembly already? Let's just say Minecraft clone. Alright. I'm going to do this again, and then I'm going to release, and I'm going to hit speed scale 1. As quickly together as possible. All right. Maybe 0.4 is a little too high. I'll do 0.3. Okay. I'm gonna stop messing with that. Steps. Make a real step. A real step. Add. Node. Visual. Geometry. CSG. Primitive. Box. Steps. Create. Material. Blue. Not blue. Let's do white. Not white. I'm just gonna do blue. I'll just do blue. Okay, so step height. 0.3. Let's go 8 meters of step. Let's go up 5 meters. And then I would just increase step height until it's... One sec, I'll be right back. I gotta go measure my steps. I want to make sure I'm not making this value insane. Okay, it looks like my steps are measured to be 7 inches, which is like about 18 something centimeters. So definitely less than 20. So I'll make it like that. All right. Go up 0.5. 1828 is a good measurement. What? 1825. I don't know what I follow. Do you? Oh yeah. I mean, I was gonna ask like, why would you know that number? But of course you know that number because you've been doing steps recently. 2.5. All right, that might... I mean, that is a pretty tall staircase, but, you know, I kind of don't care. It's going to be a tall staircase. Let's put these over here. Well, let me not do that. And I'll just rotate this around. And I guess I can number this about the step height. So I'll say this is 18. 18 centimeter step. All right, let's go see the 18 centimeter step. Backwards, of course. Oh my gosh. Perfect. Okay, let's take this camera off. Let's go back to first person now. Or just character camera. It's pretty good. Shift this. It doesn't look... It doesn't look like I am jittering. Yeah, I wouldn't even really need a ramp or a step down, in fact. This is just really good. Oh my god. I literally don't need any kind of stair logic. This is just like already pretty good. Movement's still really weird. The acceleration, the friction stuff is still bothering me. It probably needs to stop faster, honestly. I feel like 8 is not enough. Alright, from first person to 8's not enough. I need more than 8. In fact, this is deceleration now. And I'll bring this up to like 9. I'll make it 10. Okay. Let's go 14. Pretty good. Also, how does it know? This is interesting. All right, let's go back. Let's go back to the side camera. Math. Dude, this is just what happens when math is working. When math is working, it's pretty good. Honestly, this could probably just be a second camera, a new camera that I attach to the player to toggle between. All right, let's go slow motion. What's my movement vector doing? I mean, it's just so nice, and I flew off. Okay. You know what? Duplicate this and put it on the other side so I can go up and down the stairs without doing that stupid stuff. Also, I haven't looked at this yet. The spring force on the side when that's normal is different. Dude, I don't know why, just looking at these the arrows change direction is just mesmerizing to me. That's so stupid. I'm just literally looking at the arrows move around and I'm like, wow, that looks cool. Okay, so steps seem to be working. I think I'm going to go ahead and send this because this is quite a good amount of stuff here. Also, I had this today list that I was going to start and I didn't do anything. I didn't write anything on that list. Okay, let me send this. All right, plugin, curve, that's just excluded for now, the ramp, steps, debug draw. Debug draw looks like it might have a bug where drawing in the near plane is just a little bit... I mean, it is the near plane. It seemed like when things were like a vector coming back towards me, it looked like it was kind of shooting off the top. But I think I've got all the math correct. I wrote it so abstract that if it was wrong, it would be wrong a lot. It wouldn't be wrong sometimes. At least that's what I think. Okay, there's that. Character controller, I cranked up the deceleration and the damping. I'm adding the height offset instead now. I have a bunch of calculation. I have air drag, which technically limits your top speed, and it also handles when you're moving vertically or horizontally, laterally. Wait, is it like... If that's true... Is that why crabs look the way that they do and move the way that they do? I was just thinking, would it not be a strategy to run faster just by running sideways? But our legs don't move like that. But crabs do that. Crabs move sideways. Their legs are built to move sideways. Maybe that's why crabs walk the way that they walk. It's better for drag in the water, because drag matters a lot more in the water. It's almost like crabs evolved in a way that benefits them, yeah. The ideal movement for a creature is to move laterally along your thin side and your flat side. Maybe everyone's been running the wrong way this whole time. Maybe the actual fastest way has been to run sideways. Debug tool. The friction, the height offset. I'm first person by default. I move some keys around. Timescale changes. Awesome. Stable movement on inclines, fixed spring on inclines. Also added CSG extra shapes. Fixed spring on inclines. Also added timescale manipulation. Fixed spring on inclines. And then added ramps and steps to test level. Oh, and debug. I'm just gonna write this up here. Debug. Debug tool. Added debug add-on for drawing vectors and more things in the future. Handles frustum intersection for vectors that pass off screen. Man, all right. That's pretty slick. It's getting slick. Okay. I need now, I guess, to incorporate max speed. I mean, what this really means is that once my ground speed, my maximum ground speed will be modulated by the incline. Once my once my ground speed exceeds my max speed, I stop applying forward acceleration. I just don't apply forward acceleration. Which does mean I should be like kind of I'm assuming what this means if I do it like that is I'll jitter a bit. So I want to add letters. I want to add words. I want to draw words. So I'll say text. And then an ID, of course. And a time. And it returns an int. So it should look very similar to this, except I do a text thing. Type text. This will be, whoa, string, color and time. If it's a vector, string. Draw text. And I guess what I'll do is if it's in front of you, I'll draw it so that it should still be able to appear off screen. But also I think I want to scale it by distance. So that should just be, I mean, the projection is for every time you double the distance, something looks half the size. So if you're at 1 meter, you look normal. 2 meters, you're half. 4 meters. Am I dumb? Is it just 1 over distance for the scaling? I guess so, right? Draw string. Horizontal alignment. That's a lot of stuff. Okay. So yeah, for now I'll just okay, what is this? I need to know. Is it the square root? Distance, size. Yeah, because if it's like the surface of a sphere, it's like light fall off. It's exactly the same thing, right? Distance, size, scale. Inverse square? The radius. So its size should be 1 over its distance squared. But that's an area. I think it's just size is 1 over distance. I guess I'll find out later or something, if that makes sense or not. This has to... So I can just say if camera is positioned in frustum pause. I can also just check the near. Yeah, I think that's what I said. I'm checking the near plane. If it's on the near plane, nah, I'll do frustum. I'll do full frustum. If not camera dot is position in frustum pause. Return. Otherwise, should definitely be valid. And then I would do draw string. I guess fallback font. I kind of, okay, I would like to actually have a monospace font. Oh, wait, I think if I actually just do font, hang on. No? I thought there's a way to like get system font. New. Yeah, this is what I want. A system font with a font name, a pack string array, and that would just be monospace. Learn new static methods, like okay, whatever. Close, draw singleton. You could actually to use init. Will load in a font. Monospace, mono. And then if it can't find anything from there, then it's just, you know, it's lost. Yeah. That should get it. It should get that. Then I can just use font. Screen. Text. String. Alignment. Center on that, I guess. Width, -1. Font size, I will do 16 times 16 over pause distance to camera global position. Color. I think the rest of this is probably fine. Yeah, I think the rest of that's fine. All right. Draw text. And I would like to draw my velocity. So when I do debug velocity, I would like to draw that text of the velocity in meters per second. This will be percent dot 3f meters per second. And I will just use linear velocity, length, linear speed. With the color forest green. Can I see it? Nope. I mean, that's just actually not true. In fact, that's not true. Wow. What is happening there? Okay. What? Oh. Okay, let's go a little bit larger. Well, actually, play. Stop that. Let's go scene, remote. Okay, I can drag it. Camera, let's move you closer. Okay. Closer. Alright, maybe that's working. Maybe. I think I just need to actually make it a lot larger, though. Like 32. That is really difficult to see. Oh, I can read this. Okay. Interesting how I continued to accelerate over 20 meters per second. So let me just make the platform much larger, I think. This is 100 meters. Wow. 200 meters. Oh, I guess it's actually 50 meters on in either direction is really what it really is. Oh, let's not go that way. This way. I was gonna say there should be a point at which like my friction is high enough. All right, let's put this behind the player. No, I'll do it on the side. And then let's just move the player over this way. Yeah, the interpolation of that draw thing is kind of crazy. Oh, wait. Oh, I turned off. No, wait. Did I already send that? I didn't send it yet. Okay. I made a mistake. I turned off false. Keep it away. Alright, so now I'm not accelerating infinitely. 5.8 something meters per second. That's pretty quick. Let me look up. Run speeds in meters per second. What the hell? The average human sprint speed is 15 to 20 miles per hour for active adults. 12 to 15 untrained. Okay, so what's miles per hour to meters per second? (20) 9 meters per second. All right, so we're thinking somewhere between 6.7 and 8.9. So the number here looks like it's reading about 5.8 something. So it's already slower than... Also, that's a sprint speed. That's not a run speed. I would say I could go running and use that as a measure, as a baseline, but that's definitely going to be slower than I think a guy who is more active than me, wearing a super suit. So let's try to get at least 7. Well, actually, here's a good question. Oh, look, it's right there. How fast are Counter-Strike meters per second? Movement. I know they're in units, but these are like technically centimeters or something. Yeah, cannot, let's not look at that. Well, okay, this is the only site, so. Camera units per second. Are hammer units... Are those inches? Because if those were centimeters, that's nothing. Alright, well, that's like not really helpful. Alright, what is this? Reddit. What is this? Difference in player speeds? Huh? What kind of question is this? What? How does that make any sense? Can you... What? Okay. Interesting. So you guys are just sprinting all the time, constantly. All right. Meters covered over around. On average. So that means you're standing still sometimes. So you're saying that sometimes that considering standing still, you are... Huh? That's just crazy to me. That doesn't make it... I don't understand how that makes any sense. 1 user roughly 1/16 of a foot. Alright, that's what I thought. Oh, wait, I didn't see this one. One hammer unit is 1/16 of a foot. Minimum distance the source engine can measure. So if you're traveling 250 times 1/16, okay. Quick math. So this is 15 feet per second. And I believe the conversion is to inches and then to centimeters. And then I'll divide that by 100 to get meters. Okay, how does this make any sense? At knife speed, you run at approximately 4.7 meters per second at knife speed. Unless that number is wrong. Yeah, 250 is your maximum speed. That's with a knife out. 250 or the C4. So maybe I did that wrong. 250 is 1/16 of a foot, so now I have my measurement in feet. Now I have my measurement in inches. Now I have my measurement in centimeters. Now I have my measurement in meters. Do I need to do like this? Alright, well, that graph that they measured is definitely just wrong. You cannot move, on average, 11 meters per second. If the top speed you are ever capable of reaching is 4.7. Alright, well... honestly, maybe my speed's good enough. Maybe the acceleration isn't quite high enough. I still think it should be acceleration to max speed, and your goal there is to try and match those. Okay, but I've got friction turned on. Let me go back here and do get... what did I write? Git add. Let me see git diff really quick. Yeah, I just want to add that line. So git add. Just quit the rest. Okay. Essentially, that's just how I can prevent you from... Oh, that also needs to apply when you're in the air, actually. Otherwise, you can reach infinite speed when you're falling. Okay. This one isn't modified yet, but I need to compute it at the top. So vertical speed is only used for that. And this is always applied. So let me just bring this up to the top. This can just be friction, computed pretty early. Vertical velocity. So I'm just going to cut that. Vertical velocity is relative to myself. So if I were to be like, my basis was forward, then yeah, my vertical velocity is 0. Which I wonder if that's ground velocity excludes my vertical velocity, which would be that. So if my ground is like this, okay. Those are possible places that they could be wrong later in the future. So say this, add total gravity, minus friction. Right. Now here's what I want to know. What does my velocity reach if I free fall? From a very high height. Let's just throw him a kilometer into the sky. Go up there. Alright. And then I will focus and position the camera above him. So the number is correct. Because I don't think I'll be able to see that number with how much it'll be moving. But if I look like this, then the number will sit still. Okay, I cannot see the number at all. What? Why can I not see the number at all? Am I looking up? What's happening? Am I falling? I don't know what's happening. Debug isn't on? What's going on? It's all turned on. Why is it not? Oh, because debug doesn't output unless... Right. Okay. All right, I guess what I do then instead is I just say, instead of returning here, I can just say else, and then this all comes inside. One tab. And then debug enabled will have some problems. Where forward I guess forward can be computed way out here. No. No, I'm changing way too much right now. I just noticed that. I'm changing way too much. I cannot do that. I need to commit this. Or it's already committed. What's the diff? Adding font. Character controller is adding. I've moved the friction. That's adding friction there. Okay. And I'm adding the text. All right. I just want to copy this and put this up here. That's all I wanted to do before I return. Debug velocity. I'm going to copy debug friction. Okay. That's all I'm doing. .8 meters per second. I'm nowhere close. Okay. So what's the problem there then? I'm accelerating down. It appears that my gravity force has equalized at about 15 meters per second. Which just doesn't make any sense. So, is it that like... I mean, let me just print lateral ratio. Print lateral ratio. 0.5. Oh, that's just totally wrong. This should be 0. Okay, so that's why it's being weird. Linear speed, which should be 0, over vertical speed, which should be a big number. Oh, what? Oh, no, this is linear speed, and then I need lateral speed. Why did I do that? Am I using linear? I use linear speed down there. Where else do I use linear speed? I only use it for that calculation. Okay, so this is just supposed to be lateral speed, which should be the other side of that. Which can actually just be that. Okay, now I print my lateral ratio. 0. Alright, the acceleration is getting crazy. Okay. Get rid of that. And now I place the camera above the player, because now I can see it. Is that centered? Yeah, that's centered. Okay. All right, what's our speed? Do I reach 300 at a little over and no more? I'm slowing down. Actually, it'd be 135. A little bit over 135. All right, well, let's go. Let's get high. Let's put it 2 kilometers up. Higher than that. Does it really take that? I'm kind of surprised how long it takes to actually accelerate like that. So this should be like skydiving. It should reach 135 or something. When I reach terminal velocity. Okay, I mean, I'm still slowing down. That's still not enough to reach terminal velocity, though. This is over a mile up. I'll double check. I'll look at more statistics on skydiving, like as fast as possible. Because it looks like it's probably around like 125, maybe. I did math for 135, by the way. That was my math. All right. Go 10 kilometers up. I mean, if the sim, you know, my math was correct, this should approach 135 and stop. But I may still hit the ground before I reach that. I mean, I'd say I got it pretty close. If it's nearly coming to a stop at like 134, I pretty much got it right. Stops right there. Which I feel like is too early. But okay. I'm good with that. That makes sense. Terminal velocity is about 130. Which in miles per hour is... I did my math with 135. That's what I did my math with. All the math is still here, in fact. I guess I actually did round it up. It should be like 989 is closer. Maybe I'll just do that. Oh, okay. Paused apparently. So it should get a lot closer to 135. Oh yeah, it just shot past. This is less, so it still shouldn't reach 135, but it should get really close. Oh no, I rounded up. So this might actually pass 135. Okay, it did not, but it got really close. Okay. So clearly, well, I mean, I can't say clearly. I literally brute force the math with all these numbers to ensure that this value as 0.0989 would equate to approximately gravity. The acceleration due to gravity. Which, I mean, I guess that makes sense. The forces would cancel out at that point. Okay. Let me look up skydiving speeds. Oh, well, of course it's going to be the guy that jumped off in the Red Bull thing. Jumped from space in Red Bull. Speed skydiver. 298 miles per hour. Okay. That's like best case scenario. I'm just going to trust that. It's from Reddit. It's really close to what I was looking for. I saw a couple 230s. Maybe I should go less. What would be 250? 112 meters per second. Alright, I'm going to redo the math. Let's do 112. And then this number, 9.81. Actually, this also matters if my gravity is correct. What's my gravity? Gravity. 9.81. Okay. When 143. I mean, I guess this is also... I mean, this should be parameterized. These four numbers should be parameterized. That number is just going to be error. That one's fixed. Alright. So looking for 112. Something very close to 112. Slightly over, slightly under. It might also technically be correct to add gravity and then compute air resistance. But it's so close it probably doesn't really matter. Actually, it can matter for the time that it takes to reach top speed. Okay, I expected it could be a little bit over, but it's really close to 112. That is actually a concern. Should I be adding gravity before? All right. I think it might be correct to add gravity to my linear velocity and then use calculations from my linear velocity. Because I use that as my ground velocity. And also compute a vertical velocity. I'm gonna add gravity first. Subtract friction. Do calculations. Because I use my linear velocity to then calculate friction. Though it could be wrong, I don't know. This definitely changes things. In fact, I'm also applying gravity twice, so I need to make sure I remove this from here. So I apply gravity, and then from there, I apply... Because that could... I mean, it could also have the opposite effect. I could be falling faster because I'm computing my air velocity before gravity pulls me down. So there's a word where I accelerate faster. Because I computed gravity after resistance. I think I definitely did accelerate slower because I kind of... Yeah. Because air resistance was just a little bit higher every time. Let me actually do this. I want to know. Let me say in ready, I'll do... I'll probe for the very accurate value. It shouldn't be 0, right? It should be a little bit positive. I'll say if it's not equal to -1. I'll go down like 5 kilometers instead, or 6 kilometers or something. So I just fall a little bit, hit the ground a bit sooner. Microseconds should be like the millions, right? Pretty sure it's the millions. Let me check. Yeah, it's a million. Okay. Also, this is crazy. Counting microseconds, you would still have to run the program for 500,000 years. Let's go to 6. I don't want to compare how long this fall takes compared to applying gravity at the same time as air resistance. My expectation is that I fall faster. I accelerate faster, so I spend less time at a slower speed, essentially. I should hit the ground sooner. And it should be noticeable. Like probably several seconds noticeable. Okay, so I pretty much hit terminal velocity. I guess 6 kilometers was too far. Yep, I could go into 5 kilometers. But I'll run it again. I'll just run it again at 6. 62. I'll just copy this and put this up here. Okay, and then I will comment this line out and instead apply it here at the same time. And then bring it down here too. Okay. This should hit me. I should reach the ground much faster. That's my prediction. I blew way past that. Why? I shot way past that. What? Minus friction. Okay, there we go. So 62 seconds earlier, my expectation is that this did make a difference and I should hit the ground noticeably sooner than that. Wow, okay. I guess not. I guess somehow it does not make a difference. Which is surprising to me. Alright. Well, there it is. I did a test. I was wrong. But adding gravity first does make sense. I will at least go ahead and do that still. So I don't have to... Well, no, it actually didn't make any difference. It is technically, it was a little bit faster, but it seems like it didn't matter. I thought it'd be dramatic, like seconds faster. This is barely a tenth of a second faster. In fact, let me actually check the number. Is it 2 ones? I already deleted it. Well, I think I have it copied. Yeah. 0.12 minus 0.0, it's 0.06 seconds. Like that's, I think that's not noticeable. That shouldn't be noticeable. A tenth of a second is nothing. I thought it'd be dramatic. I thought it'd be really, really dramatic. Just to make sure this is still factored in there. It is. This is factored in here, and then it's not here. Okay. I gotta take the dog out. I'll be back in a minute. I'm back. I keep forgetting, I keep losing track of the time, actually. I get up and I'm like, I'll be back, and then I come back and I'm like, all right, it's over. Okay. I just needed to move this up here so I could even at least see it. And I think technically what I really want to do is make this debug stuff needs to be better. What I should be doing is printing this out as I get the information. So friction should probably print like as soon as I calculate it, or at the last point that I calculate. I don't know. There's duplication here. It's not very good. I don't think I really have anything changed. It's just added the text, and I still have stuff that I want to work on. But I do need to push my other changes. Yeah, this is just adding the text and then moving some stuff around so I can see the text. Test that. Okay. Whoosh. All right. This is going great, though. Where's the player? I can't even see the ground anymore. Let's go to 1 meter off the ground. There we go. All right. One last thing before I stop, I do want to see. I forgot what the top speed is of this guy. It was like 5.9 something, which is pretty fast. I think I'm gonna assume that most games probably don't go much faster than 6 meters per second. This is like sprinting speed. This is really, really fast. I'm sure most people probably can't run this fast. So, yep. All right. Well, that's going to be it for today. Thanks for watching. And that, I can fix that. That flashing thing, I might fix that later by having my own auto exposure. Because I wrote that. I wrote an auto exposure thing that would remember the last value. Because what happens in Godot by default is that when you resize the canvas here, it rebuilds entire buffers and it starts them off as being like black. So it applies the maximum, like a super high exposure value instantly. I guess a super low, I don't know what they do. I think it just starts off as black. But what it could do is just read in the last value and fill that in with the new, or actually they could just straight up not even compute a new, the final pixel. Because what happens is it takes a screen, it samples it down using GPU stuff to do it really, really fast to 1 pixel with a luminance value. And then it really just adds up all the RGB values and then computes a luminance value. And then it looks at another pixel, which is just a 1 pixel image, which contains the previous auto exposure value, and interpolates between this one and this one. So what happens is when you resize the screen, it has to resize all the sample buffers. But kind of by mistake, it also makes a new one of these. So this single pixel thing, which is always 1 pixel, ends up getting lost. So once it does that sample down, it compares like that value to like 0, which is why it blows up all bright, because it's not exposing it down like it should be. It's exposing it up. Also, I don't like how they do it. They consider the entire screen, which means whenever you poke your head around a corner and you see something bright, it instantly affects the screen. It should only be focused in the center, which is part of what I did too. I have a mapping function or a bias function. So yeah. But that'll be later though. That's not a big deal for now. I'll remember that because I'll keep seeing it happen. And maybe one day it'll annoy me enough that I do it anyway, but I should hold off on that. All right, well, that's it for today. Tomorrow is just continuing this, really. I have the stable movement. It seems like it's really stable right now. So now I'll probably just have acceleration and stopping rate That's actually done. Stopping rate's done. Deceleration's in there. I need to have a proper acceleration and a proper top ground speed. And ideally what you would do is I would have an acceleration rate that it'll just be an acceleration that keeps applying to it. And ideally I would have to set that to a high enough value, because I think right now, yeah, it's like 4, an acceleration of 4, which is probably pretty slow. I mean, maybe it's not that slow, but it could be a little bit faster, I think. The issue is definitely top speed. Actually, let me see how long it takes me to reach the top speed. Okay, so it takes like 2 to 3 seconds to reach 5. So an acceleration rate of 4 is probably slow. I just want to look at this to see if zombie game is faster than that. It's got to be more than 4, I think. Character, player, it's probably going to be here. Okay, it uses the default value. Oh wow, my move acceleration is 20, so it's really high. Also, I use 15 there, which is even higher than what I have. I don't know, does that seems fine to me though. 8 seems good. Also, it's funny how friction looks like it just sticks to the ground. Okay, so yeah, apparently my values in Zombie Game are cranked way higher than that. What's my top speed? .8. So I've actually got you moving slower than like a sprint. I'll figure it out. But I got some good movement stuff there that I can copy, especially the jump. The jump is going to be the slope as well. Do I have that? Yeah, I need to say slower on upward slopes, faster on downward slopes, which I think it just means I reduce my acceleration when I'm going up by the factor of how much up I am going. And then max slope angle, I need to define that too. Okay, well, that's it for today. Thanks for watching. I'll be back tomorrow to hopefully get all of this stuff done. Hopefully it's not too much. The hard math has been figured out at this point, I think. The hard math has definitely been figured out. Cool. Goodbye.